Welcome to the DIY Honda Garage channel. The DTC P0222 indicates a low voltage reading from the Throttle Position Sensor (TPS) B circuit in the Honda Odyssey model years 2011 to 2017. This error often points to potential communication issues or electrical problems affecting the throttle body component, critical for engine management. The throttle position sensor plays a vital role in relaying the position of the throttle plate to the Engine Control Module, ECM, or Powertrain Control Module, PCM, which in turn adjusts fuel injection and ignition timing accordingly. Notably, the TPS-B, usually marked by a purple wire, should provide an appropriate voltage for proper engine operation. The sensor itself is located on the throttle body, which is situated near the intake manifold, making it easily accessible for inspections. Understanding and troubleshooting this DTC is essential for maintaining optimal performance and efficiency in the vehicle. DTC P0222 is related specifically to Throttle Position Sensor B, which is responsible for providing real-time throttle position data to the PCM. This data is essential because the PCM uses it to make immediate adjustments to engine performance, impacting acceleration and fuel efficiency. The TPS sensor is typically located on the throttle body assembly, where it can directly monitor the throttle plate's position. Any issues with this sensor can result in incorrect readings and subsequently poor engine performance. Thus, understanding the precise location and function of the throttle position sensor is critical. The throttle body itself is typically found at the intersection of the air intake system, serving as a gateway for air entering the engine, making this area a focal point for diagnostic troubleshooting. Several possible causes may lead to the DTC P0222 appearing. First, wiring issues like shorts or disconnections between the TPS and the PCM may hinder communication, resulting in a low voltage signal. A second consideration is faulty connections at the throttle body itself, where loose or corroded terminals can interrupt the electrical supply. Furthermore, the possibility of a malfunctioning PCM cannot be overlooked, as this component is crucial for processing input from various sensors, including the TPS. It's important to systematically diagnose these areas, as electrical issues can be intermittent, and initial tests may show the system functioning properly despite underlying problems. Ensuring all connections are secure and resistance values are within expected ranges forms the backbone of this troubleshooting process. Experiencing symptoms linked to DTC P0222 can significantly affect the vehicle's overall performance. Common issues include poor engine performance, characterized by lack of acceleration or hesitation during throttle application. Drivers may also notice stalling, especially during rapid acceleration or deceleration, which can cause unsafe driving conditions. Additionally, dashboard warning lights may illuminate, signaling that there is an underlying electronic issue that needs addressing. In some cases, rough idling may occur due to incorrect throttle position readings, affecting engine air-fuel mixture. Recognizing these symptoms early is vital to prevent further engine damage or loss of vehicle control, emphasizing the need for immediate diagnostics and corrective actions. The first step in diagnosing DTC P0222 involves turning the ignition switch to the on position, which powers the electrical systems in the vehicle without starting the engine. This allows access to the vehicle's onboard diagnostic system. The next action is to clear the Diagnostic Trouble Code, DTC, using the Honda Diagnostic System, HDS. The HDS is an advanced diagnostic tool that provides real-time data and capabilities for scanning vehicle codes. Following the code clearing, it's crucial to check the Throttle Position Sensor B, TP Sensor B, using the HDS to observe voltage readings. The ideal voltage reading should be around 0.3 volts or less. If the reading aligns, it suggests that the fault is likely persistent and verifies the DTC is legitimate. Otherwise, it may indicate an intermittent issue, advising further inspection of connections and wiring. In the second troubleshooting step, the next move is to check for any pending or confirmed DTCs using the HDS. This step is critical because it helps determine if other trouble codes, specifically P0122 alongside P0222, are present simultaneously. If both codes are indicated, they may correlate, suggesting a more systemic problem within the throttle position circuitry or the throttle body itself. If only P0222 is confirmed, it directs us to continue to further diagnostic steps, specifically creating a focused approach towards the wiring and individual connections leading to the sensor. Establishing the presence of multiple codes can significantly help in pinpointing the root cause and elaborating testing sequences. As part of the third step in the troubleshooting process for DTC P0222, turn the ignition switch to the lock position to ensure all electrical systems power down before proceeding. This is a safety measure necessary for handling electrical components without risk of shock or short-circuiting. Next, disconnect the throttle body 6P connector to focus solely on the TPS without interference. Following this, jump the SCS service check signal line using the HDS. This action supports electrical testing by simulating the circuit functionality. Establishing proper communication after jumping the SCS line allows further evaluations of the electrical state of the TPS and assesses any irregular signals that might lead to low voltage readings indicated by the DTC. In the fourth step of troubleshooting DTC P0222, one must turn the ignition to the lock position again for safety. Proceed to disconnect the PCM connector B, which is marked as 49P and is critical in relaying information between various engine sensors. After this, continuity testing is performed between the throttle body 6P connector terminal number 4 and the body ground. This is a crucial step because if continuity is present, it indicates a path for the current to flow. Securing that connection is vital for operational performance, as any break or short in the wire could directly lead to inaccurate voltage readings at the TPS. If continuity is not found, further investigation is warranted to repair the wiring between the throttle body and the PCM, which may include insulation damage or complete wire breaks affecting signal transfer. Finally, in the fifth step, connect the throttle body 6P connector again before turning the ignition switch to the on position. Measuring the voltage between throttle body 6P connector terminal number 5 and the vehicle body ground is paramount for this step. This voltage measurement will give insight into whether the TPS is functioning as intended under load conditions, as well as confirming that the wiring and connections are intact. It is essential to ensure that this terminal's voltage is at expected levels. Discrepancies suggest a failure in the circuit or in the TPS itself. Post-testing, if the results fall within expected ranges, it may confirm further diagnostic steps are unnecessary. Otherwise, further disassembly and testing may be required to chase the source of low-voltage faults. After completing the repairs related to DTC P0222, it is crucial to perform a final repair verification session. This begins with a test drive of the vehicle under varying conditions to observe how the engine responds to throttle input. During testing, monitor for any recurrence of the DTC and ensure that no warning lights reappear on the dashboard. Post-test drive, it's vital to check the DTC status again using the HDS to confirm that the code has been fully resolved. The successful outcome will demonstrate that the vehicle achieves optimal performance without hesitation, stalling, or warnings. Final verification not only solidifies confidence in the repair, but also serves as the last step in ensuring the vehicle's reliability and safety on the road. To prevent future occurrences of DTC P0222, implementing regular preventive maintenance is essential. A proactive approach includes routinely inspecting electrical connections around the throttle body and PCM for signs of wear, corrosion, or looseness. Maintaining a clean throttle body is equally important, as buildup of carbon deposits or grime can hinder sensor performance, leading to inaccurate data readings. Furthermore, ensuring that only high-quality parts are used for any replacements or repairs contributes significantly to the longevity of vehicle components. Establishing a maintenance schedule that includes these checks not only aids in preventing fault codes, but also enhances the overall performance and reliability of your Honda Odyssey. In conclusion, understanding the implications of DTC P0222 is vital for proper vehicle maintenance and performance. It is crucial to recognize the role of the Throttle Position Sensor B and its influence on overall engine management systems. Following each of the diagnostic steps methodically allows technicians to pinpoint issues with accuracy, ensuring that appropriate repairs can be executed efficiently. Moreover, implementing preventive strategies to maintain electrical connections and sensor cleanliness can greatly reduce the risk of recurrence for this fault code. By addressing DTC P0222 effectively and promptly, drivers can ensure enhanced vehicle safety, performance, and driving satisfaction in their Honda Odyssey. Please like and subscribe to the channel. See you next time!